All right, let's spend a few minutes reviewing this. And I'm going to turn the timer on this time. Let's just get an idea as to how long it's taking you to do these. Only because that's important. In other words, if you can do them 100% accurate, that's great. But if it takes you 20 seconds to do each one, you end up using a calculator because it's faster. And then the moment you go to a calculator, 2 months later, you've forgotten everything. In other words, the only way you remember your multiplication tables is if you keep practicing them. It's like playing the piano. I used to play the piano, but I haven't had a piano in 10 years. I cannot play a note. So everything is all about keeping practice.
It's going to be positive 15.
And that was 10 seconds. This one?
That is 13.
9 seconds. Go ahead.
-8.
Good.
That is -13.
Good. This one is 12. But I don't like the fact that they give you those. And that's not what you need to know. You need to know single digit that results in a single digit answer.
That's going to be a -6. -60. -6. 7. -1. Or -1.
-1.
That's -10. -8. -11. At positive 54.
Good. I was going to say, remember the rule of nines.
That's going to be a -19.
Good. You immediately figured out how to, that means a minus and a minus.
That's going to be a -5.
Good. All right. That's enough. That's pretty good. You've gotten better at that. Quite a bit better. And the better you can get your speed, the better yet that you'll be. All right. Let's go back and talk about factoring. Factoring is the next big thing that we're going to have to cover, and it's going to be a number of sessions. There's a lot that goes into factoring. The first simplest kind of factoring was greatest common factor. That's always your first step. When you look at an expression and somebody says factor it, the first thing you want to try to do is there a greatest common factor? Yes, there is, and it leaves that. Okay? Let's talk about difference of perfect squares. Difference of perfect squares basically means this. That's a perfect square, a squared, and b squared is a perfect square. Well, that always factors into a minus b times a plus b. Such that if we had x squared minus 4, what's that factor into? I can't quite hear you, Chris.
x minus 4.
It's minus 2. And the reason is that this first expression, notice that A is the square root of this, and B is the square root of this. So to get what difference of perfect squares factors into, just always take the square root of that term and the square root of that term. And you only need to get the first term, because the second term is what?
2.
Plus 2. It's always the conjugate. It's always the same two terms, only with the opposite sign. So, what if I had this? What's that factor into? What's the square root of that? Remember the name. The name is difference of perfect squares. So we're only going to use this if both terms are perfect squares. In other words, if I make that an 8, that's not a perfect square. So I wouldn't be able to use it if it was an 8. But as long as it's the difference of two perfect square terms, then we can use this factoring technique. What's the square root of 4x squared?
2x on
Yeah,
both sides.
2x, exactly. Let's just do the left side. In other words, this is a little different than normal factoring. In other words, here, if we can get the left side, we don't need to do any work to do the right side. And the left side always a negative. What's the square root of 9?
Square root of 9.
What two numbers multiply together to give you 9?
3 and 3.
So this one is automatically 2x plus 3. Okay? And now, the one difference of perfect squares that a lot of people don't notice when they see it is this one, or anything that has 1. What's that factor into?
1.
Exactly. X minus 1 times x plus 1. In other words, that's a perfect square, and that's a perfect square. 1 is a perfect square number. 1 squared is 1. So it qualifies. So when you see a 1 as that constant, know that you're still looking at difference of perfect squares. How about if I did that? Is that the difference of perfect squares? No. That is not a perfect square. There is no whole number that multiplies together to give you 2. So this is only going to apply if we have the difference of perfect squares. How's that factor?
Alright, so the first part's going to be 8x minus.
Okay, now let's put that 8x minus what?
5.
Now, ask yourself, does that squared equal that? Because that's what has to be true. What's 8x squared?
8x squared is
Yeah, exactly. Okay. So that's not right. And you should always be doing this check every time you factor. You should, at the very first thing you write down, before I even wrote down that, you want to square this to make sure that it's equal to this. And it's not, but what is? Square root of that. There you go. Now 4x times 4x is 16x squared. So we got the first term right. Next term's always minus. What's the square root of that? 5y. Notice that 5y times 5y is 25, but you got to multiply the y times the y, so that's 25y squared. And what's the second term?
4x plus 5y.
So that's really all there is to difference of perfect squares. It's very simple. You just take the square root of this term and the square root of that term and translate it to these two things. All right, let's move on. The last and most difficult part of factoring is when you are factoring a quadratic. For example, x squared plus 7x plus 10. Now, this is a quadratic, but so was difference of perfect squares. They're both quadratics, but difference of perfect squares is a very certain type of quadratic that I can factor in the way that I did it. This is a different quadratic. It's a quadratic because it's got that in it. That's all it takes to be called a quadratic, is an x squared term. Okay? Now, first step in factoring, is their greatest common factor?
No.
Good. Is it difference of perfect squares?
No.
Okay, so that leaves us with this technique. And I'm sure you've seen this, haven't you?
I think.
Where you take a quadratic and you separate it into two linear factors. Now, what we're doing, in other words, let's just go back one step and make sure that you can multiply those two linear factors. These are linear because x has an exponent of 1. That's what makes that a linear factor. Well, that's the same thing. It's a linear factor. When I multiply a linear factor times another linear factor, I get a quadratic like this. So let's make sure you know how to multiply those two together. How would you multiply these two? I'm not quite sure what you've been taught. Do they call it FOIL? Is that what you've been taught? FOIL is pretty standard, is what's taught, and it means first, outside, inside, last. First, outside, inside, last. What's the first terms multiplied together? What they mean by that is there's the first, there's the outside, there's the inside, and there's the last. So there's it. I call it ET, which means every term by every term. But there's a little bit of an advantage in using the term FOIL. It works particularly good when you are dealing with two terms times two terms. Doesn't work real good when you have two terms times three terms, whereas my ET works perfect. But there's something to be learned by FOIL also. So, what's the first term times the first term? X squared. Yeah, if I wrote it exactly as you said it, I would have wrote it like that. X2, which means X times 2. So, you don't want to refer to it that way. It's one of the advantages of online tutoring is it gives you a chance to verbalize stuff, which you probably never get when you're in a classroom. How often do you have to get up and actually verbalize a math problem? Not very often. So this is helpful to you. Okay, what's the next term? Outside. What's that times that? That's x2. But we like to put the coefficient in front. In other words, we're going to write it as 2x. You with me? What's the third term? What's the inside? And finally, what's the last term? What is it? It's plus 10. In other words, I can't just write 10 there. It doesn't have any meaning if I don't know what it's doing. It's being added to these other three terms. So I need the plus there. Not because it's a plus 10, but I need to know what it's doing, and it's being added. Okay, now, whenever you multiply a linear term times a linear term, the only thing you can combine is the two middle terms. There's no other x squareds, there's no other constants. But there's a 2x and a 5x. How many x's is that? 7x, yeah. So, that's my final answer. Okay? So, what we're doing when we're factoring is unmultiplying. We have to make sure that in the end, this times this is equal to this. So let's go through the steps at doing this. And this is a relatively simple quadratic. There's two types of quadratics. There's quadratics that have a 1 as the coefficient of the x squared term. Those are the easy ones. Any quadratic that has a number other than 1, like 3 or 2 or 6, something like that, those are hard quadratics. And I break them up into those two categories. Now, mainly what you're going to be dealing with for a long time is easy quadratics. You won't have to do hard quadratics. So, I have a very easy method for factoring easy quadratics. They may teach you something in school that's called the California method, which is hard, confusing, complicated, and difficult to understand. So if they teach it to you and you have to know it, then you're just going to have to learn it. But let's teach you how to do it my method, which is really easy. There's 3 steps. That's it. First step, break up your x squared. You break it up by this. After you break it up, you make sure you multiply it back together again. Does that equal x squared? Yes, it does. I'm done with step 1. Step 2. This is very important because this is the one that most of my students forget, is step 2. Step 2 is determine both signs. Well, how do you do that? Well, if you look at the sign that is associated with the constant is 10. It's got a plus sign in front of it. That means that these two signs have to either be both negative or both positive, because that's the only way you're going to produce a plus. They have to be the same. Well, if they're the same, I still don't know whether they're negative or positive, but if I look to the sign on the middle term, that's what they both are. In other words, these are both pluses, and that's what I mean by figuring out both signs. Easy enough?
Yeah.
Step 3. And this is the one I want you to learn and learn how to verbalize it. And step 3 is factors of 10, meaning two numbers that multiply together to 10, that add, because of that plus sign, to the number 7, the coefficient of the middle term. Not the plus 7 necessarily, but the 7, just the number. So what factors of 10 add to 7? This is really where you need to know. This is the primary reason you need to know your multiplication tables and division tables, because a calculator is not going to be helpful to you here. A calculator cannot find factors of 10. The only way you can do it is to know your multiplication tables. So what two numbers multiply to 10 and add to 7? All right, let me give you a little help. When you're trying to figure out factors of a number, start with 10 and 1. That's always factors of a number. The next step is, if you can, cut that in half. And by that I mean, if you can cut it in half and it's still a whole number, then do it. And double the other one. In other words, if I cut 10 in half, it's 5. If I double 1, it's 2. Now notice, I can't do that again. I can't cut 5 in half and have it be a whole number. So I can't go any further. So this is actually my complete set of factors. 10 times 1 is 10, and 5 times 2 is 10. So I'm looking for the factors that add to 7. Clearly, those add to 7. There's my answer. Let's do another one. Tell me first and second step. That's step 1. Step 2, determine both signs. Positive and positive. And finally, step 3, verbalize it. Factors of 12 that do what? Add up, because of that, to the number 4. Well, what factors of 12 add to 4? What's the next set of factors I can get? Ah, that's the answer. Right? Oops, excuse me. Excuse me. I meant, sorry. I meant to make this a negative sign. Well, let's go back. Let me start this from scratch. I got the wrong number there. Let's see. What I wanted was minus 7 plus 12. Okay. Now, let's go back and do it. Step 1. Step 2. What does this plus sign mean?
That the right side is going to be adding.
It means that both signs are going to be the same. Remember, step 2 is to determine both signs, not just one. Both signs have to be the same. The only way I can produce a plus 12 when I multiply these two things back together again is if the signs are the same. Well, what must they be? Negative or plus?
Negative.
Because of this one. So they have to both be negative. Okay, now step 3 is what? Factors of 12 that do what? That add up to 7. Factors of 12 that add because of this to the number 7. Not the negative 7, but just to the coefficient number. Well, that's pretty easy. That's 4 and 3. In other words, if I continue my factoring, I started with 6 and 2. Well, I can still cut 6 in half and double 2. So there's another set of factors. Now, these are the factors that add up to the number 7. So one goes there, the other goes there. That's my answer. All right. More difficult step, but still not level 2, would be if there's a negative sign in front of the constant. If there's a negative sign in front of the constant, there's 4 steps, not 3. But the first 3 are still the same. There's just a 4th step. So the first step, x and x. Now, how was I able to produce that negative 12? What does it tell me that the signs have to be? They have to be opposite. They can't be the same. If they were the same, this would not be a negative 12. This would be a positive 12. So the one thing I know for certain, because there's a negative sign in front of the constant, that the signs are plus minus or minus plus, but in this case, plus minus and minus plus are the same thing. There's no difference. Okay, so I'm done with step 2. Now step 3 is very, very close to the old step 3. It's factors of 12. But instead of adding to 4, they need to subtract to 4 because of that negative sign. So what factors, and not the negative 4, but the 4, what factors of 12 subtract to the number 4? Let's list factors of 12 again. Which pair subtract to 4? Okay, so here's my factors. Now, the 4th step, which goes whenever there's a negative sign in front of the number, the 4th step is to decide which number goes with which sign. We didn't have that problem before because both signs were the same. So the rule is take your biggest factor, the 6, and put it with the sign of the middle term. Well, the sign of the middle term is negative, so that's where I'm going with the 6, is right there. And the other is 2. And that's how you do elementary factoring. Now, we got another minute. Now, the way I would prove that this is correct, in other words, just to know that you've done it properly, you need to multiply it back together again. Well, if I FOIL these two things, I get x squared minus 6x plus 2x minus 12. Well, the only two terms I can ever combine are those. So now I got x squared minus 4x minus 12. That's what I started with. I've done it correctly.
Alright, cool.
Okay? Alright. We'll pick up with more factoring next time. I'll talk to you next Tuesday. Alright, Chris. Bye-bye.
Alright, Chris.